Exercise 2.2, question 1. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Part 1. X squared minus 2x minus 8. We'll solve this by splitting the middle term method. For details on this method, you can refer to the video on the topic of splitting the middle term. Here, minus 2 will be split into minus 4 and plus 2. Hence, our polynomial becomes x squared minus 4x plus 2x minus 8. Taking two terms at a time, x taken as common, leaving x minus 4 in the bracket, plus 2 taken common, again x minus 4 leaving in the bracket. Now from these two terms, x minus 4 is taken as common, leaving x plus 2 behind in the bracket. We know if a multiplied by b is equal to 0, it means either a is equal to 0 or b is equal to 0 or both are is equal to 0. So, x squared minus 2x minus 8 has two factors, x minus 4 and x plus 2. If the product of these two factors is equal to 0, it means either x minus 4 is equal to 0 or x plus 2 is equal to 0. If x minus 4 is equal to 0, it means x is equal to 4. And in case x plus 2 is equal to 0, then value of x is equal to minus 2. So 4 and minus 2 are the zeros of this expression, which are denoted as alpha and beta. So alpha is equal to 4 and beta is equal to minus 2. Now let us verify the relationship between the zeros and the coefficients. The coefficient of x squared a is equal to 1. Coefficient of x, that is b, is equal to minus 2. Constant term c is equal to minus 8. We know that sum of zeros, that is alpha plus beta, is equal to minus b over a. Now putting the values, alpha is equal to 4 while beta is equal to minus 2. Minus b here is minus 2 over a, that is 1. On simplification, we get 4 plus minus 2 is equal to 2. On the right hand side, minus minus plus becomes plus 2 over 1. So 2 is equal to 2. Hence, relationship of sum of zeros is verified. We also know that alpha multiplied by beta is equal to c over a. Putting the values, alpha is 4 and beta is minus 2. C is minus 8 over a, that is 1. On simplification, 4 multiplied by minus 2 is equal to minus 8 and minus 8 over 1 is minus 8. Hence, relationship of product of two zeros is also verified. 4s square minus 4s plus 1. Again, we will simplify this by splitting the middle term method. Here minus 4 will be split into minus 2 and minus 2. Let's rewrite 4s square minus 2s plus 1. From the first pair of two terms, we'll take 2s as common, leaving 2s minus 1 in the bracket. Now minus 1 will be taken common, leaving 2s minus 1 in the bracket. Now from these two terms, 2s minus 1 is taken out as common, leaving 2s minus 1 in another bracket. We see that both the factors are the same. So 2s minus 1 is equal to 0, or 2s is equal to 1, or s is equal to 1 upon 2. So the 0 of the expression 4s square minus 4s plus 1 is 1 by 2 and 1 by 2. So here alpha is equal to 1 by 2 and beta is also 1 by 2. In the expression, a being the coefficient of s square is equal to 4, b being the coefficient of s is minus 4, and constant term c is equal to 1. Let us verify the relationship between coefficients and zeros of this expression. Sums of 0 are alpha plus beta is equal to minus b over a. Putting the values, alpha is 1 by 2 and beta is also 1 by 2, minus b is minus 4 divided by value of a, that is 4. On simplification, we get half plus half is equal to 1. Here minus multiplied by minus is plus 4 over 4, resulting 1. Hence the relationship of sum of zeros is verified. We also know that alpha multiplied by beta is equal to c over a. Putting the values, alpha multiplied by beta, c, that is 1, over a, that is 4. On multiplication, we get 1 by 4 in left hand side is equal to 1 by 4 on right hand side. Hence, this is also verified. Part 3. 6x square minus 3 minus 7x. First of all, we'll have to write it in the standard format, like 6x square minus 7x minus 3. Now we'll split the middle term. So minus 7 will be splitted into minus 9 and 2. 6x square minus 9x plus 2x minus 3. From the first set of two terms, we'll take 3x as common, leaving 2x minus 3 within the bracket. Now plus 1 will be taken as common, leaving 2x minus 3 in the bracket. Now here 2x minus 3 is common in both the terms, leaving 3x plus 1 within the bracket. Now these two factors are equal to 0. Hence, either 2x minus 3 is equal to 0. If so, 2x is equal to 3 and x is equal to 3 by 2. So the first 0 of this expression alpha is equal to 3 by 2. And now if 3x plus 1 is equal to 0, then 3x is equal to minus 1, or x is equal to minus 1 upon 3. So second 0, beta, is minus 1 upon 3. A being the coefficient of x square is equal to 6. B being the coefficient of x is equal to minus 7. And the constant term c is equal to minus 3. Let us verify the relationship. Sums of 0, that is alpha plus beta, is equal to minus b over a. We'll put the values. alpha is 3 by 2 plus beta is minus 1 upon 3 is equal to minus 7 over 6. We'll take the LCM as 6. So 2 divide 6 3 times. So 3 multiplied by 3 is 9 plus 3 divides 6 2 times. 2 multiplied by minus 1 is minus 2. Minus minus becomes plus. So 7 by 6. Now simplification on left hand side. 9 minus 2 is equal to 7 over 6. And value of right hand side is already 7 by 6. So the relationship between the sum of zeros and the coefficients is verified. Alpha multiplied by beta is equal to C over A. Putting the values, alpha is 3 over 2 multiplied by beta minus 1 over 3. C is minus 3 and A is 6. On multiplication we get minus 3 over 6, and on the right hand side it is already minus 3 over 6. So the relationship between the product of zeros and the coefficients is also verified. Part 4. 4u square plus 8u. The standard format of this expression is 4u square plus 8u plus 0. 0 is the constant term, but the net value of the expression is 4u square plus 8u itself. So we'll take 4u as common, leaving u plus 2 in the bracket. Now there are two factors, 4u and u plus 2. If 4u is equal to 0 or u is equal to 0 by 4 or is equal to 0. So the first 0 of the expression is alpha is equal to 0. If u plus 2 is equal to 0, then u is equal to minus 2. Second 0 of the expression is minus 2. Here A being the coefficient of u square is 4, B the coefficient of u is equal to 8, and the constant term C is equal to 0. Let us verify the relationship. We know that the sums of the zeros alpha plus beta is equal to minus b over a. Putting the values, alpha is given as 0 and beta is minus 2. Minus b is minus 8 and a is 4. So 0 plus minus 2 is equal to minus 2, and here 4 cuts 8 by 2. So right hand side is also minus 2. So the relationship between the sum of zeros and the coefficients is verified. As far as product of zeros is concerned, alpha multiplied by beta is equal to C over A. Putting the values, alpha is 0 multiplied by beta, that is minus 2. C is 0 and A is 4. 0 multiplied by minus 2 is 0 and 0 divided by 4 is also 0. So the relationship between the product of zeros and the coefficients is also verified. Part 5. T square minus 15. Here we see that the term of t is missing. So the standard format of this expression is t square plus 0t minus 15. Now we notice that t square minus 15 is in the form of a square minus b square. This identity gives us a plus b and a minus b as its two factors. we take t plus root 15 and t minus root 15 as two factors. Now, if t plus root 15 is equal to 0, then t is equal to minus root 15, that is alpha. And if t minus root 15 is equal to 0, then t is equal to root 15, that is beta. Here, a, the coefficient of t square is equal to 1, b, the coefficient of t is equal to 0, and c, the constant term, is equal to minus 15. Let us verify the relationship between zeros and the coefficients. We know alpha plus beta is equal to minus b over a. If we put the values, alpha is minus root 15 and beta is plus root 15. Minus b, it is minus 0 over 1. Negative and positive equal terms cancels, so left hand side is 0 and right hand side is also 0. So the relationship is verified. Alpha multiplied by beta is equal to c over a. Putting the values, alpha is minus root 15 multiplied by beta plus root 15, c is minus 15 and a is 1. On multiplication, we get minus 15 on left hand side and minus 15 on right hand side. So relationship between the product of zeros and the coefficients is verified. Part 6, 3x square minus x minus 4. So the middle term is 1, which will be splitted into minus 4 and plus 3. We will rewrite this like 3x square minus 4x plus 3x minus 4. From the first two terms, we will take x as common, leaving 3x minus 4 within the bracket. From the second pair of terms, we will take 1 as common, leaving 3x minus 4 within the bracket. Now in both the terms, 3x minus 4 is common, leaving x plus 1 as another factor. Now if 3x minus 4 is equal to 0, it means 3x is equal to 4 or x is equal to 4 by 3. So alpha is equal to 4 by 3. If x plus 1 is equal to 0, x is equal to minus 1. So second 0, that is beta, is equal to minus 1. Here we have a being the coefficient of x square is equal to 3, b being the coefficient of x is equal to minus 1, and the constant term c is equal to minus 4. Let us verify the relationship between the zeros and the coefficients. Alpha plus beta is equal to minus b over a. If we put the values, alpha is 4 by 3 plus minus 1 to minus b minus minus 1 over 3. Now addition, we get 1 by 3 on the left hand side, minus minus plus, so 1 by 3 on the right hand side too. So the relationship between sum of zeros and the coefficients is verified. Product of zeros, that is alpha multiplied by beta, is equal to c over a. If we put the values, alpha is 4 by 3 multiplied by minus 1, c is minus 4, a is 3. On simplification, we get minus 4 by 3 on the left hand side and similarly minus 4 by 3 on the right hand side. So the relationship between product of zeros and the coefficients is verified.